Hello and welcome back to California Geology. I am Dr. Robert Lopez. Today I'm going to continue on with deserts and talk about playa lakes and some of the Pleistocene lakes that occurred in the California deserts, the Ice Age lakes, and then maybe on some of the minerals that we find out here. So here are some photos of a trip that I took out to the Death Valley Playa maybe like 8 years ago with some students, but remember, a dry lake bed, and one of the key things about these lake beds is that there must have been water here, right? And in fact, in Death Valley here, the water level was probably as deep as 600 feet deep, and the lake stretched for about 100 miles. And then actually back to this is looking to the south in Death Valley, there's a butte out here, a hilltop called Shoreline Butte. And on Shoreline Butte, there are actually wave-cut benches from where the waves would crash against this butte and make these notches, leaving an ancient shoreline. So we know that the lake level must have been as high as those benches. So in this playa here, this valley, the lake level, which geologists call Lake Manly, was 100 miles long, about 600 feet deep. Now, if we look at a sort of a topographic map, a relief map of the western United States. And so this encompasses the western Great Basin. So you see the Central Valley of California here. Here's the Sierra Nevada. So there's our Owens Valley, Deep Springs, and Panamint Valley, and then here's our Death Valley. But you can see is that we have these basins and ranges and basins and ranges. So it dominates this region of the United States called the Great Basin, but geologists like to call this area the Basin and Range Province. And if we look at all these basins, we find that they're occupied by salt flats, which means that the water has evaporated away and left behind these salts. So this is a picture looking from the north east back toward the west. So California, Owens Valley is here. And then here's the Sierra Nevada right in here. Now, just before we leave, you've probably heard of a very large lake here. A little bit is left in Salt Lake, so in Utah. So Salt Lake is another Ice Age lake, a Pleistocene lake. And you can see it was part of a much bigger lake here. And this playa here is called Lake Bonneville. So when Salt Lake City or Salt Lake was higher, it was called Lake Bonneville during the Ice Ages. And then also up in like the Carson area, there's another area where there was a very large lake here. And this is called Lake Lahontan. Lake Lahontan, another Ice Age lake. But we'll talk about some of the ones as we go along here. Now, these Pleistocene lakes, so playas are very abundant in the desert. Remember all those salt flats. So there must have been water there. Remember the last Ice Age, this Pleistocene epoch ended about 11,700 years ago. And based on carbon dating and maybe dating of volcanic ashes that are intermixed in some of the dry lake deposits, we can get a pretty good chronology of lake levels in the California deserts. And it seems like between 11,000 and 13,000 years ago, we had a high stand of all these waters. Now, you may ask, where did all this water come from? Well, as those glaciers that were in the Sierra Nevada were melting, a lot of the meltwaters, obviously they ran toward the ocean westward, but many of them went into the California deserts, into the California Great Basin, and then eventually Mojave Desert region. And many of these basins in the basin and range have what's termed an internal drainage, which means that the water doesn't flow to the ocean. It flows to basins that are internally, right? They're internal drainage. For example, Lake Manly or the Death Valley Playa is the lowest point in the U.S. So that's one of the interior drainage basins. And your book mentions that. Now, let's look at, well, here's a volcanic ash. So here's volcanic ash and lake sediments in this Pleistocene Lake Russell. So Mona Lake, when it was bigger, was called Lake Russell. And so by getting dates on these, we can figure out dates on the volcanic ash. We can figure out the lake levels in the past. One thing about a Pleistocene Lake Russell is that it did not overflow 11 to 13,000 years ago because the lake level wasn't high enough for this overflow. But certainly going back between 25,000 and maybe 100,000 years ago, it did overflow at some point. But here's how we can get a chronology of the sediments here. And then this is a map showing how water would move from Owens Valley down here to China Basin. This is China Lake here, Cyril's Lake, and then flow into Panamint Basin here, and then into Death Valley. And here's that shoreline butte that has the wave cut benches on it. And then any water coming from this Amargosa River would flow to Lake Tecopia, and then that would flow into Lake Manly, again being one of these internal basins. So here's a little bit about Lake Manly here. Now, this picture is a little bit different from the one in your book, but it shows like Lake Lahontan up here, part of Lake Lahontan, the southernmost end. And there might have been a connection with Mono Lake, but certainly Mono Lake, this lake was called Lake Russell when it was during the ice ages, so it would drain to the Adobe Basin or to Long Valley and make its way down the Owens River to make Owens Lake. And then we'd flow down to China Basin, and this is the Cyril's Basin, Cyril's Lake, and then into Panamint Valley, and then finally into Death Valley. And then there's the Amargosa Basin, Lake Tecopia, and then also going into Death Valley. What I wanted to point out here is this this Mojave River. So Mojave River, it's mostly dry. Every once in a while it has a little bit of water in it, but by the time it gets past Lucerne over here, it's dry. And actually, it really travels in the subsurface as groundwater for some distance up to about Barstow. But you can see during the ice ages, this river would flow. In fact, the main course, it would take it out to this Soda Lake, Soda Basin here. Here it's called Silver Soda Basin. But Soda Lake, it's a dry lake bed. And then some of that water would flow down into the Mannix Basin and Ludlow and out to Bristol Basin, Cadiz and Damien, eventually to the Colorado River. So during the ice ages, this was a channel flowing out to the Colorado River. So again, just about every basin in the Basin and Range had water in it, right? Now, what is the evidence? So I always ask the question, what are the two lines of evidence that indicate high lake levels during the Pleistocene time? Now, one are these strand lines. Remember, the strand lines are the old shorelines where wave cut benches forming, indicating where the water levels were in the past, sort of like a bathtub ring. And then the second one are these tufa towers. And tufa towers are really a chemical precipitate of calcium carbonate, which makes the mineral calcite. But these form where spring waters coming from the Sierra snowmelt carrying calcium ions will interact with briny waters in these evaporating lakes and make these structures called tufa towers. And I'll show you some of those. Now, here's a picture of Mono Lake. We're looking from east to west. So here's the Sierra Nevada over here. And these lines you see here, these are the strand lines, right? So this is showing where the lake levels were in the past. So those are good examples of strand lines. And then the whole shoreline over here by Navy Beach in this western southern shoreline here has these tufa towers. The thing about the tufa towers, the way they form underwater. So that means in order to form these towers here, the lake level must have been above the height of these towers. Lake level above the height of these towers. And this is an image from your book, Figure 619, showing how rain and snow from the Sierra Nevada will percolate. These calcium-bearing waters will come, and then as they'll percolate up, bubble up into the carbonate-rich waters, the briny waters of Mono Lake. In fact, your book has a little excerpt from one of Mark Twain's books called Roughing It, where he describes Mono Lake and how alkaline the waters are, and how basically how you can do your laundry in a matter of minutes, and if you put the alkaline waters on your hair, you can make lather 3 inches high. It's a little exaggerated, but if you do swim in Mono Lake, you find you can float very easily because it's very salty. It's saltier than the ocean. And then once that water dries off you, you get little salt crystals on your body. So it's an interesting feeling. But nonetheless, what happens is these calcium-bearing waters percolate and they interact with the carbonate and they make calcium carbonate. So the only way to make these towers is to have the tufa towers underwater. Now, this is some pictures of the pinnacles or the tufa towers at Trona. And Trona is the Searles Lake. So remember, there was China Basin, and then Searles Lake, and then the Panamint Valley. So this is on the way to Panamint Valley, and you see these structures. And these are 50, 80 feet tall. They're very tall structures. And here's a close-up of one. And so another thing to notice in this picture, here's one of the tufa towers, or pinnacles. These are bigger than the ones at Mono Lake. But one thing to notice in the background, these lines, those are the strand lines, right? So you can see the old lake levels up in here. And when these were forming, they were forming underwater. Now, Mono Lake is another Ice Age lake. And up to about 1913, it had water in it, up to maybe 20, 30 meters deep. It was a blue Ice Age lake, Pleistocene lake. But in 1913, the Department of Water and Power of Los Angeles started diverting water from the eastern Sierra Nevada. And basically, in a matter of a couple of years, Owens Lake went dry. And so here's an interesting picture showing the high Sierra Nevada, the rugged peaks of the high Sierra Nevada. And this is the aqueduct system that the Los Angeles Department of Water and Power diverts water out to LA. And but one of the problems they've been having is because once the lake went dry, all these salt flats, their crystals were being blown up by winds and causing these intense dust storms. And one of the salts that forms in these lake beds is an arsenic salt. So people were getting health hazards. So it's a health hazard. And so I think it was in 2006, a lawsuit came out where basically the Department of Water and Power for Los Angeles has to control the dust problem here in the Owens Basin, and they're doing it by putting some water back in. They have these sprinkler systems that try to keep the dust down. They put gravel bars. They plant vegetation. So they're trying to do a number of things. They are actually putting some work into it. And another reason to protect this region is that there are many exotic species of bird that visits the lake. This is an ibis, the white-faced ibis, a very beautiful bird here. And then the American avocet. American avocet is popular there. And also there's pelicans, and there's this number of yellowhead blackbirds and red-winged blackbirds. And the most abundant seabird that occurs here is the seagull. But there's a variety of species that occur there.